Hello there. My name is Chris Fernandez. I'm a solutions engineer with Keysight Technologies. Today I'm going to go over 802. Some of the TSN specific testing. In this case here, I'm going to be demonstrating our ability to test 802.1 QBV, and that's our timeware shaper. So implementation. I'm going to be using the NXP Switch for our DUT in the middle, and I'm going to be using the following configuration. So if you take a look at this screen now, I have you can think as the first test port as my grandmaster clock here, and my secondary port as my other bridge port here. And I have a third port that's not participating on the AS itself. It's unscheduled, and I'm calling it a background traffic should be adding complexity to this topology here. My main goal is to make sure that my mission critical traffic is undisturbed. In my case here, I created a 1,000 microsecond time window or cycle, and in that cycle, I have 4 gates, right? So 4 opportunities to transmit on each VLAN priority. I assigned VLANs priority 0 through 3 on gate number 1. On gate number 2 is my mission critical traffic. I'm going to treat that as my mission critical, and that is mapped to VLAN priority number 4. And on my gate number 3, it's going to be VLAN priority 5, and on my gate number 4 is going to be my last gates here, which which translates to VLANs priority 6 and 7. The way I determine how many packets I can send on a single gate without having any violations, I can see there's a description here on how I configure that, and then there's also a implementation here of how many of my DUT, my topology. Right, so I have ports number 13 going to SPW0 here. This is a switch configuration, so this is what we call it a bridge, right? So I have ports 13 going SPW0, SPW1, which is my egress port, which is where the traffic is going to come out. So the implementation of the gates is actually done here at this egress port, and I also have another ingress port going from ports 16 here or 15 to my SW1, which is my background traffic, right? In terms of the gates, I'm on the configuration on the DUT. I'm actually implementing something called a guard band. A guard band is nothing but an empty gate, meaning that nobody can transmit at that time. Usually you put a guard band right before your mission critical traffic is supposed to be transmitted. And the way we determine how big your guard band should be is based on the biggest packet that you are allowing to be sent on your network. So in my case here, the biggest packet size is 18 bytes, and I configured by doing this calculation here, I can tell that in order for me to transmit and not allow any bigger traffic, any packets to be transmitted right before I open up my gate for my mission critical traffic, it's about 12 microseconds here. Unfortunately, my NXP switch does not allow me to do the 12 microseconds, so I had to increase that to 50. So my guard band is kind of big, which is not really the case for many DUTs. And as you can see here, I'm going to bring up my my DUT here. And we can take a look at my my configuration. So the configuration is done on SPW1, which is my egress port. Over here, I'm just doing the mapping, and my schedule here is that for gate Number one, I'm opening up for 200,000 nanoseconds or 200 microseconds. I have a 50 microsecond gate here or guard band, which I do not allow any traffic to go through. So all the gates are closed at this time. And then I have my mission critical gate here, which is my VLAN priority 4. And then I have the following two gates, the 5 and then 6 and 7. So that configuration is applied to my SPW1, which is my egress port. So now that I have that, what I'm trying to do and the configurations on the DUT all set and done, I'm going to go into my configuration for Ixia. So first things that you got to do on the Ixia side, on the traffic, if you go on the traffic and you look at my global options and then you go and show all, you're going to go under here, schedule transmitting settings. This is where you're going to click here to schedule transmit setting, and this is where you input your cycle time. So my cycle time is 1,000 microseconds or 1 millisecond window here, and this is pretty much all you need to do here at the global level. Now at the traffic level, I have my traffic here is all unapplied. I can take a look at my overview here. Everything is up, so I have my grandmaster here, my follower port here, my follower here or follower or slave, and then this is my background. So as you can see here on the port, I have two device groups. One of them is for my GTTP protocol, which does not require any VLANs, or you cannot have VLANs on that. And then you have another VLAN here, and I have another IP here. So you can see that in this configuration here, I have I'm using 172.16.0 as my IP address, so I can forward traffic. And this is the other IP address. And my background traffic does not have any GPTP configuration on it. So at this point here, everything is up and running. So I have my AS synchronized. So I have both parts of this 2-arm test already synchronized. You can see here my follower, or the slave, is in slave mode, and he has an offset of close to 0 nanoseconds. So it's actually pretty good. And we can take a look at also the path delay. The path delay is about 250 nanoseconds, which is par and reasonable for us to continue the test. For port identity, you can see here that my port identity for my master is actually my grandmaster clock that I'm using for my slave. So, and the master here, this MAC address here is actually going to be the MAC address of the switch, because the follower here has the switch as the master, and the grandmaster is actually going on the other side. So if we take a look at the switch itself, we can take a look at some implementation of the IS2S. So I'm just going to look at here, just so we understand what's going on. So I'm telling it on the FGTP here, just to give us an idea here. So I'm going to stop this. So you can hear here that's port 0, which is the connection to my grandmaster here. The role is a slave, and I can see the propagation delay is 351. And then on my port 1, which is connected to my slave here, the role of that port is master, and I have a propagation delay around 336. So everything is running accordingly to plan here. I have my my GTP running on a single domain 0, and it's up and running. So at this point here, I have my configuration for my my gate and my PTP running okay. So the last step here, if you look at the traffic here, I have 3 traffic items here that I configured. The last one here is just the ARP table. This is just so I don't have flooding happening on all the ports. If I have, when I'm sending traffic to a single destination, that destination is not going to be a learning because it's not sending any traffic except when it comes up. So in order for us to, for demonstration here, I'm just using this as a way to send traffic and getting the the ARP table to be populated on the DUT. So I'm gonna what I'm gonna do here is just generate all, and then I'm gonna apply that traffic, and I'm gonna send this traffic for a little bit. This is 1 frame per second, so just to get the table, the ARP table done on the DUT without having to do flooding to do any more learning. So if I send this traffic here, I can send this traffic for a few seconds. So, and then we can take a look at the table here. So for just completion here, we just take a look at the forwarding table, the forwarding database on the bridge. And you can see here, those are my SP2, SP1 interfaces and SP0, right? So everybody is already learned, like the switch is not going to have to do any flooding to nowhere just to send traffic to, right? So this is all this traffic is for. It's not really useful for our testing itself. We can ignore for now. So I'm going to stop traffic for now. For this traffic, and we're going to start sending the real testing traffic, right? So I'm going to stop this for now. I'm going to disable it. I'm going to disable it, and I'm going to enable the traffic that is supposed to be transmitted on time correctly. So for that, let's take a look at what is that traffic really is. It's just traffic with a bunch of frames here. So I can I can change the rate. Let me change the rate because I'm not sure. Let's do 200 frames per second. I'm going to apply that. Actions on generate all. That should be applied to all of them. Duplicate that on all rows. I said OK. Those two traffic, the background traffic and the ARP table traffic, are disabled right now. So I'm going to generate all and apply again. So now we have a frame size of 100 and 200 frames per second being applied to those 4 flow groups. So there is one traffic item here, and with 4 flow groups, which represents the gates. Right, so if we take a look at them, the difference between them is they all look the same, except that when you take a look at how we send them under the transmission, so in order for us to hit the first gate, we send it with 0 delay. Now the second gate is, we're going to put in a 250 microseconds delay in that traffic, and this traffic here is 500 and 750 and so on, right? So this is traffic is instrumented, so when we arrive at the gate should be open and the traffic should flow right through it, right? So that's the instrumented traffic that we're sending from the master to the follower, right? So we can start that traffic at this point. So I'm gonna start traffic at this point and look at some stats, correct? So I'm applying the traffic and sending the traffic. So let's go back now. So as soon as it starts running, okay, we can start running. We're gonna look at the flow statistics, and we can see a couple things being what's happening there, right? So we're sending traffic for VLAN priority 0, 4, 5, and 7, which represents the gates that we're opening and closing, right? And we can see here under a couple things here when we take a look at. First, we take a look at the latency, right? So the latency for all of them are very close, meaning that there's no much difference between all the traffic items. So the traffic items, as we know, is working. So the first packet of this first flow is arriving. When the gate opens, we send that traffic across, and it closes and it goes through, right? We can see that they are all sending packets at the different times, but the latency is very similar to each other. Another thing that we can take a look, it's over here on the absolute first timestamp. If we look at this, the dot here, think of this as a nanosecond delay precision. So we ignore the first 3 digits here, and we look at the middle 3 digits here. So you can see that the first group, or gate 0, is being sent at 002 time frame. The second one is 252, which is 250 after that, and then 502 and 752. So the packets are going across and hitting the gates when the gates are open. So this is working correctly. So now we can ask, so how is this working, or how do you verify that this is actually working? So one way of doing it, if you go back into the traffic here, and we're going to stop the traffic, and one good experiment that we can do by looking at the gates, and if the gates are working correctly, it's by changing the way that we send traffic. So let's say, for example, that this flow group here, which is the last gate, should be sent at 270 microseconds, right? So we're going to go in here and under transmission, and we say that to 0. So what that means is that this last item here, traffic flow group here, is coming in when the gate 0 is open, right? So he's not supposed to be sending that because his VLAN priority is 7. So he's coming in at the same time as gate 0. So gate 0 is going to be open for VLAN's priority 0 to 3, but this traffic item here, or flow here, is VLAN priority 7. So what I expect when I send this traffic is that the gate for this priority 7 only going to open after 750 microseconds. So my expectation is that this flow group here is going to have a 750 microseconds latency attached to it, and that's exactly because the switch is going to have to buffer that and only open the traffic when it's appropriate to send the traffic out. So let's send the traffic and verify that, right? So we applying the traffic after we send, we check this, and we go back to statistics, to flow groups, flow statistics, and we can take a look at the latency for that specific group. So everybody else should be coming in at the right time, and they should be flowing through, but that this gate 7 here should be coming in at the wrong time. So we're going to look at the latency, and exactly what we see is that the latency this has been delayed now by 750 microseconds because it's coming in at the wrong time. All right, so this is one way of checking this. So this is working correctly, so the gates are working fine. So at this time here, we're going to stop traffic again. I'm going to fix the flow group for that last traffic item that we just modified, right? So this here. So under continuous here, I'm going to add my 750, so he is going to come back in as correctly. So this time around, I'm going to actually add the background traffic. So what the background traffic is it's a bunch of packets that are not instrumented. So they're going to come in at any time, and it's going to be hitting every gate except VLAN priority 4 with my mission critical traffic, right? So I'm going to open here, and I generate all, and I apply. And the expectation is that every other gate now it's going to be buffering traffic. So I'm going to actually amp this guy here. I'm going to make this 100% line rate. So I'm going to kind of flood the gates here. So I have two ports sending traffic to one, right? So it's going to be more than we are allowing, right? So we're going to generate that, and we're going to send the traffic. So what I'm expecting now is that all the gates are going to be flooded, and what I'm going to observe is that all the latency on all the packets should be more than what we did before when there was only instrumented data, right? So now we have VLAN priorities from 0 all the way to 7, and the background traffic here, I'm not sending background traffic to VLAN 4, which is my only traffic that I'm concerned about. That's my mission critical traffic that I want to preserve. So what I expect is that this traffic here should have the same latency that we did in the beginning, and every other traffic should have greater latency because now it's being impacted by this background traffic that is hitting the gates when the gates are closed. So if we take a look at here at now my latency, right? So we can see exactly that it's happening, right? So this is VLAN 0. This is my mission critical traffic. You see that it's still around 2,000 nanoseconds, and it's not fluctuating. But every other VLAN priority now is getting flooded with the background traffic, and it's impacting the latency, right? So everything is working accordingly, right? So we have the nodes on the same time, so they are on the same time zone, and I'm sending traffic correctly, and I can see the impact of background traffic on top of my mission critical traffic, which is done by this VLAN here, right? So anyway, this is all I want to show. This was kind of a long video, but it kind of demonstrated how we can test QBV using IxNetwork. If you have any questions, feel free to reach out to us, and we'll be glad to share more information or debug together. All right, thank you. Bye.